Hi everyone. In this lecture today, we are going to talk about graphs. I just want to go over this. This should be a review. For these notes, you're going to be on page 22 of your interactive notebook. We are going to talk about the three major types that are important to scientists. So we're going to talk about line graphs, bar graphs, and pie charts. There are other types of graphs like a scatter plot, but scientists don't necessarily use those a whole lot, and we won't use them in class, so I'm not even going to touch on that one. I'll leave that for Miss Hart to do in math because I know she teaches that. I want you to understand why you choose the graphs that you do. There are exceptions to some of these rules, but for the most part, the reasons I'm going to give you for which graph you choose will work for you pretty much every time. So during a lab, if I ask you to graph your data, you can graph it appropriately. We are doing graphs in our interactive notebook, and I'm having you do it as a bar graph because we are doing different root charts. So there's a reason why I'm having you do it that way. The first thing I want to talk about is why we use graphs as scientists or just as people in life. There are certain times as you get older, when you get into whatever profession that you are going to use, that you are going to have to look at data. Education, ever since I've got into it, I've been in it for 5 years now, there has been an incredible push to start using more and more data. When I went through grad school, this was just getting started, and that was about 10 years ago. When I first started teaching, it was like data explosion. Everybody expected you to look at the data and to judge what is going on. So a lot of professions use a lot of data in order to justify whatever it is that you want to buy, what you want to do, the path you want to take. A lot of things will require you to be able to analyze graphs. So one of the first reasons why we like graphs is because it's visual. A lot of people are very visual learners. The use of graphs will allow you to visually represent your data, and it allows you to be able to do the other kind of two things. The second thing, which is really important for scientists, as part of our scientific method, once we have the data, we got to figure out what that data means. So if you can visually represent it, it also makes it easier to interpret. I can pull whatever I am trying to get out of it and answer the question that started me on this path. So it allows you to look at your data and interpret it and come up with what you got out of that scientific experiment a lot faster. The third thing, it allows for predictions or for the making of predictions. Scientists are really big about making predictions. One thing that I love to talk about in biology when I teach it is the flu shot. What scientists will do is they will look at what happened the year before and make predictions on what the strain of the flu could be the next year in order to make a vaccine to get us ready for that new thing. So it's just an easier way to kind of see your data, analyze your data, and then make a prediction based on what you are going to see. First graph that I would like to talk about is going to be your line graph. And I'm going to go back and forth between my yellow notebook paper and an actual graph because I'm going to have you do kind of a mock graph on your page just so you have it, just so you can see all the different things that you're going to have to include if you want to do a graph completely. So for a line graph, the main reason why you would choose this is because it tracks changes over time. Time is your most important factor when it comes to your line graph. This is why you choose a line graph, is because you are doing something over time. It could be using numbers, it could be using years, days, seconds, minutes, hours, whatever that case may be, years. I think I already said that. It could be looking at months. So you could also be looking at January, February, March. That's still over time. So you could choose a line graph to do that. So one thing to kind of keep in mind that kind of gives this one away is that your x-axis is almost always numbers. Not always, but for the most part, it is almost always in numbers. A couple of things just to remember. Whenever you do have a line graph, make sure you connect your data points. You'll be amazed at how many papers I will grade that you have all your dots, but you don't connect them. So what's that going to show you? The reason for a line graph is to have a line on it. So make sure that you connect your dots once you are done. As an example for this one, I'm going to switch over to some line paper, and we are going to do a quick little chart. I'm going to go through everything that you need to remember to have on here, things to keep in mind, all those different things. So you can do this in your book. It doesn't have to be perfect, but I want you to make sure that you understand all the stuff that I am going to be requiring you to have when we do a graph in a lab or on a test or something like that. For the example for the line graph, I'm going to have you chart out just something that I'm just kind of making up. It's all going to be kind of just random numbers, but I'm going to have you look at the number of 8th graders per year. So we're going to look at it over a couple of different years. Now, one thing that you need to remember whenever you do a graph of any kind is you got to have a title. That should probably be one of the first things that you are going to put into whatever chart, whatever graph you are doing. So title would be number one, number of 8th graders. The second thing is you got to figure out what your X and Y axis are going to be. Because this is a line graph, your x-axis is almost always going to be over time. So we're going to do this over years. So down on the x-axis, I'm going to skip every couple of lines and I'm going to put in a year. Now on the x-axis, you can do this. You can skip lines and it's not that big of a deal. But when you move up to the y-axis, you need to make sure that your lines all make sense. That if you skip a line, that it makes sense, and I'll explain that once we get to it. I'm gonna kind of do this backwards so that I know that I get all my years in there, and I'm not gonna put the 20 in front because I kind of have limited space on the screen I'm using. So I'm gonna do 16, 2015, 2014, 2013, 2012, and 2011, just so I know I had enough room for everybody. So that's going to be my x-axis. Now you also have to give this a title. This, because it's all in your 2012 through 2013, this is your year. So that's my title for my x-axis. And I'm sorry you kind of can't see that because my dashboard is in the way. But a year is written underneath all of those, so make sure you have that. Now, when you move to the y-axis, you've got to make a scale that makes sense. You've got to come up with something that will include all of your data points, and every single line means something. I'm going to just say that we are going to go by tens. So if I were creating this scale and I wanted to skip lines, I can do that as long as I obey the scale that I chose to use. So if I'm saying that this right here, of course, is 0, the down part of the scale is, then my next line up is going to be 10. I don't necessarily have to write 20 on the next line. I could skip it and go 10, 20, and then 30 up the side. And then I can keep going with my scale. So 30, 40, 50, 60, 70, 80, 90, 100, and then I guess I'm going to have 110. I don't think I needed that much. But all my lines make sense. So if you are going to skip and not label everything, make sure it makes sense, because otherwise I will take points off of that. If you went just from, if you did your scale instead, like you started with your 10 here, and then you said that next line was 20, I would not accept this, because the scale does not make sense unless you're going to tell me that you went by 5s, but because you started 0 to 10, you're not doing it by 5s. So make sure that your scale makes sense. Then we'll just start plugging in some numbers. Say in 2011 there were, I don't know, 70-something kids. I don't know. Just put a dot somewhere between 70 and 80. In 2012, say it dropped a little bit and we had like 60 kids. In 2013, it skyrocketed and we had 102 kids. 2014, maybe we kind of stayed on par and we had 90 kids. 2015, I can actually tell you how many we had. We had about 150, but that won't fit on my scale. So we're just going to say that there were, I don't know, 100 kids. And then 2016, this wouldn't fit on the scale either, but I'm going to say it dropped a bit and we're back down around something like 79. So I know you can't see it on my screen just yet because my computer is being slow, but I got all my points put in, roughly where they are. Then once your points are done, you've got to connect all of this with a line. Now make sure that you go in order and that you get everybody involved. Don't forget to connect or do it out of order, because then that messes things up. And then that's it. I mean, oh, if you're paying attention, what did I forget to do? I forgot to label my y-axis with a name for my scale. I'm doing the number of students, so this would be numbers. Number of students. Sorry, mine's a little screwy, but it still works. So that's all the stuff that you kind of have to remember. For a line graph, make sure that you connect the dots. Make sure you do them in order. Don't get them out of whack. Otherwise, you're going to have to like go and white it out or start over. For every graph that you ever do, you need titles on everything. So a title for the graph itself, a title for the y-axis, which I almost forgot, and a title for the x-axis. For the bottom, you can skip lines, and that is just fine so that you can space out your data, and most people will do that. For your y-axis, make sure that your scale makes sense. If you're going to skip lines, make sure that you account for that and you do the 10, the 30, the 50, or if you're doing it by fives, then you start off with the 5 and then you go to 15 or whatever the case may be. You don't always have to fill in your chart completely, but you have to have it make sense. So that's a line graph. Going back to my other page, let me go back to my paper that I was using before. Next one that we are going to talk about is a bar graph. You guys are doing this one in order to track your root information, your root scores, and we're going to do that all year. But bar graphs, the reason that you're choosing it is because they compare groups within a common category. So you're comparing something within a commonality. So we could look at like the brand of shoes, we could look at the number of people with blue eyes or brown eyes or something like that. We can look at specific traits that have variances throughout our population, throughout the buying world. We can look at those different things. So you're looking at a group within a common category. They fall under one heading. I chose to do it with the roots because you're looking at roots, but then we have a different set of root words every single time. For this, remember, just like in your line graph, your x-axis is something specific. In this, your x-axis is going to be the groups that you are working within. So no numbers, it's going to be names, and you're going to have your groups. Going back to my line paper, let's do a very quick graph on this. I'm going to do my favorite ice cream. If I was in class, I would ask you what your guys' favorite ice cream was, but since I'm sitting here on my couch doing this, then I'm going to have to choose just the ones that are popping into my head. So we're going to just do a chart documenting basic information about ice cream. On my title, I'm just going to put ice cream. You could put favorite ice cream or top ice cream, whatever you wanted to choose as your title. Your title is kind of your own thing, as long as it kind of lets you know what in the world's going on. And then down on my x-axis, this is going to be the type of ice cream. And because I have kind of limited room, and I know you guys can't really read that, it says type of ice cream, I'm going to do abbreviations. A lot of times you don't want to do abbreviations when you are working within this, but I have to kind of do that in order to make it all fit, because it's not that easy doing this on my like little iPad. The first ice cream that I'm going to choose is my favorite ice cream, so I am going to put chocolate chip cookie dough. And I'm just going to abbreviate it as CCCD. Another one, if I was going to pick my husband's favorite ice cream, it would be double chocolate, or double dark chocolate, so DDC. He loves chocolate, more so than I do. And then one of my other favorite ones is fish food. If you've ever had Ben & Jerry's, fish food is one of my favorites. My parents are going to come in this weekend, and so my dad's favorite is Rocky Road. And then my mom's favorite is just straight up strawberry, so I'm just going to put that. So I'm going to kind of represent my family. Then up my y-axis, this is going to be the number of people that like these different types of ice cream. My F looks really weird, I'm sorry. I'm going to do a slightly different scale. I'm going to go by fives this time, so my 0 is starting in the corner, and my first line that I'm going to come to is a 5. Then I'm going to go up my scale by fives, but I am going to skip. So 5, 10, and then I'm going to write a 15, and then a 20, 25, 30, 35, 40, 45, and then 50, 55 on up my scale. So I skipped lines, but I accounted for that in my scale. So make sure that you do that. I will be a real stickler for that. Because I like chocolate chip cookie dough so much, I'm going to say that one's the winner. And I am going to draw in a bar graph and say that 43 people like my chocolate chip cookie dough. And I'm going to color it in as best I can. Then for the double dark chocolate that my husband absolutely adores, I'm going to say that that is around, 30 people. And I'm going to color that one in. Fish food, that's, I think, kind of an acquired taste, so I'm going to go with maybe 18 people. Rocky Road, definitely an acquired taste. I don't like Rocky Road, so I'm going to say only 2 people that I polled liked it. Sorry, my dad, his favorite, not so much. And then strawberry, a lot of people like strawberry, so realistically, I'm going to say it's less than my chocolate chip cookie dough, but I'm going to say maybe it's around, 38. And then that's my bar graph. I've documented all my different information. Okay, so you just get that all in there. You've got your titles, you've got your scale that works, you plot your information, and you are done. For the last chart or graph that we will use, it's a chart, but we are going to sometimes use pie charts. And I will do these sometimes when we talk about grades after a test. I really like to sometimes compare different classes. So I like to look sometimes at pie charts, and I can present the information in that. I think out of all the charts, this one is the easiest one to work with because it's all you gotta do is draw a circle and divide it out. This one, the kind of characteristics is it shows parts of a whole. And that's kind of the key. You're looking at, a lot of times, percentages. Often, the data is a percent. But this is not always. This is a rule of thumb. Sometimes it is, sometimes it is not, but not always. A lot of times this will be presented in a percent, but don't bank on that every single time. For this one, all you got to do when you want to do it is you draw a circle because you're doing parts of a whole, so think of it kind of like a pizza. You're going to divide out your pizza based on the information that you have. My data that I'm going to use is, say we were doing something with science grades. You just had a test, and I'm comparing how you did within that class or within the whole 8th grade. We could do it that way, but a lot of times I like to compare classes because sometimes if a class does really, really well, I might have to reward them with donuts or something. So keep that in mind. Because you have grades, then you would have A, B, C, D's, and F's, and you can chart them. I'm going to say that I'm an amazing teacher, and you guys are amazing students, and you studied and did your job, and I had a good chunk of A's. So just over maybe 25% A's. So there's my A's right there. Roughly, maybe, 27%. Then my B's come in and say that those are roughly about the same, maybe a little bit less, and my B's are going to go right there. And they're going to be about 24%. Then the not so great grades. C's, yeah, they're okay. I'm okay sometimes with the C, especially if it was a really hard unit. D's and F's not so much, but C's I can handle. I'm going to say that is about, 15%. Then we're going to just take the other one and we're going to divide it in half and say whatever is left, that was our D's and the F's. So you just take the information that you have and you break it down. Sometimes the easiest way to do this is by starting with your biggest numbers and then working down to the smallest. That's usually how you would look at this and how you would plot it. When you go to do the assignment with this one, it'll be a lot easier with the information that you're given. Start big and go small, and usually you'll be just fine when it comes to creating a pie chart. Now, before I wrap this lecture up, I'm going to go through kind of the things to remember just to have a list. So things that you need to remember when you are doing this. So remember, 1, you need to label everything. Make sure you have your titles for your graph itself. You have your title for your x-axis, y-axis. You have everything labeled because I will look at that. Then the second thing that I want you to remember is to choose wisely. look at your data. Make sure you are choosing the appropriate graph to represent your information. One thing that you could look at in order to help you do this is if you look at the independent variable. And you should remember what this is. This is the variable that you change, that you manipulate when you are doing an experiment. If you look at the independent variable, this is your key to choosing what's on the x-axis and which graph that you need to choose. Okay, so that's my lecture, and that is for all of my regular science classes. This is your last lecture of this unit. I will be back on Monday, and I can't wait to meet you guys, and we'll get our year started together. Good luck on your assignment.